Hi everyone, and welcome to our video on the introduction to inverse trigonometric functions. So inverse trigonometric functions are the reverse of what we usually do with regular trig functions. So you'll see what I mean in a minute, but let's break down what their graphs look like just real quick and to show that they have certain restrictions. So the sine inverse, so remember the little negative symbol, just like with regular functions. So remember this means the inverse of f of x. Okay, so it doesn't mean, so it's not a power. So it's not using that rule. So that's not a power. Okay, so same deal with these inverse trig functions. So sine inverse of x is how that's said. And similar with the cosine inverse of x and tangent inverse of x. All right, so the sine inverse of x, let's break down so I'm gonna draw a sketch for just the sine part. So that's what all this space is for. So the sine function has this curve to it. So if we graph it on our xy axis, it has this curve where those are important x coordinates, and then these are the peaks of the y coordinates. Okay, so just real quick, so even if we haven't studied the sketches yet, or if we have, we're just going to use this for a quick second. So it goes back to our rules for algebra. An inverse has to be able to only cross the graph once horizontally. So if I draw any horizontal line, it should only cross once. Well, sine inverse, that's not going to, or with the sine function, that's not going to happen. So what they do though is we restrict it. So let me erase that in the red. So we don't want that part. Instead, we sketch it the other way. So this is just one period of sine. It goes like that in the other direction. So it goes everywhere. It keeps going over and over and over again. But what we do is we take where this bottom peak is on the left, and the top peak is on the right of the y-axis, and we say, well, in between that space, any horizontal line would only cross through once. So that's the region where we would want the inverse. Okay, so our inverse function, so we're going to do just a quick sketch. So we have a golden rule with inverses, and that is to switch the x coordinates and the y coordinates. So where this positive pi over 2 is on the x-axis is getting switched to be on the y-axis. The negative pi over 2 on the x-axis is getting switched to be on, or I said y-axis, on the x-axis is now getting switched to be on the y-axis. And then those peaks, the 1 on the y-axis is now going to be a 1 on the x-axis, and the negative 1 is going to be on the x-axis as well. And let me draw that a little bit better. So I think I drew the 1 a little too far, maybe about there. So there's 1. Okay, so trying to keep it somewhat to scale. Okay, so because pi is about 3, so those should be a little higher and lower than they are to the right and to the left of 1 and negative 1. All right, and then, well, those points would still match up. They just take a different little curve to get there. So it looks something like this for that region. Okay, and the whole reason that I just wanted to do this sketch is to show, well, the domain of our sine inverse function, remember domain involves the x coordinates, would be from -1 to +1. So it's saying those are the values, so the domain is what goes into the x. And then the range, let's mark that in blue, the range, the smallest it is to the biggest it is from -pi² to +pi². That's the range. Okay, and these can be converted to degrees if we needed to. Okay, so but for now they're usually in radians. Okay, and the range, that's what this whole thing would equal eventually. So we plug in something into the x and we get something in the blue. Okay, just like any function. So you plug something into the x, eventually you get a y coordinate. Okay, so that's the domain and range. So of just the sine inverse. Now, if you do want to see the sketches, I mean, we could plug those into Desmos to really see it, but to skip the actual sketches, usually we don't need to make the graphs. I just wanted to do the one. Cosine inverse is similar. The domain, anything going into that x, must be between -1 and +1. And its range, though, is a little different. It will be from 0 to pi. Okay, so what this means, when we do plug in something into the cosine inverse, our answer should always be between 0 and pi. Okay, so we've got these different answers depending on which inverse trig function we're using. Okay, so, and these are in radians, but again, maybe if we wanted to, here's their answer, or here it is in degrees. So -90 degrees to +90. 0 degrees to 180 degrees, just in case. Okay, so it might depend on the problem. Okay, and then the tangent inverse. Tangent inverse, its domain, you can plug in whatever you want into the tangent inverse. Okay, so because our tangent inverse, well, here's our tangent function. Let's go ahead and actually sketch that real quick. So there's the y equals tangent inverse, or tangent of x, sorry. The inverse function, let's actually sketch that. So remember, these are where asymptotes are. X equals pi halves, and x equals -pi halves. If we take the inverse, those would become horizontal asymptotes, like such. And then it turns into something like this. So this is the tangent inverse graph. Just switching our x's and y's. I just focused on the asymptotes to get this new inverse function graph. Okay, so again, the x coordinates based on this sketch are anything. So the domain is, you could plug anything you want into there. Notice the range though, those asymptotes are telling you the range. Okay, so we've got, they aren't included because they're asymptotes. So it's similar to the sine inverse, but they're parentheses. So it's -pi halves to +pi halves, or -90 degrees to +90 degrees, if we're in degree mode. Okay, so that's how we find the domain and range to all of these. Okay, so let's actually put a pause on this, and then we will use these in another video to evaluate certain functions. Okay, so thanks for watching. See you next time.